Welcome back to Future Minds Jane AI Data Science Podcast. I'm your host Manav. I'm thrilled to have you with me for our 12th episode. Last time we delved into fascinating world of generative adversarial networks, exploring their components, training process, application challenges. Today we are going to shift our focus to another vital topic in AI, transfer learning. Transfer learning has revolutionized the way we approach machine learning tasks by allowing us to leverage pre-trained model, adapt them to new problems with limited data. Let's dive in. Introduction to transfer learning. Transfer learning is machine learning technique where model used developed for one task reused as a starting point of model on a second task. This approach is particularly useful when we second task has limited data as it allows the model to benefit from the knowledge gained from the first task. Why transfer learning? Data efficiency. Transfer learning reduces amount of data required for training new data as a model already possesses some learning features from the pre-trained phrases. Reduced training time. Leveraging pre-trained data models significantly reduces the training time for new tasks. Reduce the model's task from acknowledgeable state rather than from scratch. Improved performance. Pre-trained model often achieve higher performance on new tasks compared to model trained from scratch, especially when task data is scarce. Type of transfer learning. Domain adaptation. The source target tasks are similar, but the data comes from different domains. For example, model trained on English text can be adapted to work on Spanish text. Cross task transfer learning. The source and target tasks are different, but the knowledge from the source task helps improve performance on the target tasks. For instance, the model trained on image classification can be adaptation of object detection. Common transfer learning scenarios. Feature extraction. Using pre-trained model layers as a fixed feature extractor for new tasks. Pre-trained model ways are often only final layer is trained on the new data. Fine tuning. Starting with pre-trained model, continuing the training on the new task with entire model including the pre-trained layers. This allows the model to adapt the pre-trained features or to the new task. Popular pre-trained model. ImageNet models. Models like VGG, ResNet, and Inception are pre-trained on the ImageNet dataset, which contains millions of images across thousands of categories. These models are widely used for image-related tasks. But bidirectional encoder representation from transformers BERT is pre-trained on large text corpora and is commonly used for natural language process tasks. And GPT-3 generative pre-trained transformer is state of the art language model pre-trained on diverse text data, enabling it to perform wide range of language tasks. Transfer learning in practice. Image classification. Suppose we want to classify medical images into different categories, but we have limited label data. We can use pre-trained model like ResNet and which has been trained on millions of images. By fine-tuning ResNet on our medical data image data set, we can achieve high accuracy with minimal training time. Steps load the pre-trained dataset, a ResNet model, replace the final layer with new layer matching the number of categories in our dataset. Fine tune the entire model only on final layer of medical image dataset. Evaluate model performance, adjust hyperparameters as needed. Example 2. Natural language processing. Suppose we want to build sentiment analysis model for movie reviews but have small dataset. We can use pre-trained BERT model, fine-tune it on our dataset to achieve high performance. Load the pre-trained BERT model, add classification layer on top of BERT to output sentiment predictions. Fine-tune BERT on our movie reviews dataset, evaluate model performance and adjust hyperparameters as needed. Transfer learning challenges. Domain mismatch. If the source and target domains are significantly different, the pre-trained model may not perform well on the new task. Fine-tuning strategies and adaptation, domain adaptation techniques are essential in such cases. Catastrophic forgetting. Fine-tuning pre-trained model on new task can sometimes lead to model forgetting the knowledge it acquired during pre-trained techniques like gradual unfreezing and using lower learning rates can mitigate this issue. Model size. Pre-trained model, especially large one like BERT and GPT-3, are required substantial computational resources for fine-tuning. Efficient transfer learning techniques, hardware optimizations are crucial to address the challenge. Advanced transfer learning techniques. Few shot learning aims to enable the models to learn new tasks from only few examples. Meta learning and prototypical networks are common approaches in the area. Self-supervised learning. Self-supervised learning leverages unlabeled data to pre-trained models, which then can be fine-tuned on specific tasks. This approach reduces the dependency on large labeled datasets. Multitask learning. Multitask learning involves the training model on multiple related tasks simultaneously. This approach allows the model to learn shared features that benefits all tasks, improving generalization. Case study. Transfer learning in healthcare. Transfer learning had shown remarkable potential in healthcare, particularly in medical imaging and diagnostic. Let's consider case study where transfer learning is applied to detect diabetic retinopathy. This condition can lead to blindness if not detected early. Problem: diabetic retinopathy detection requires analyzing retinal image, but labeled data is limited. Solution: use the pre-trained data like Inception trained on ImageNet dataset. Fine-tune the model, smaller dataset, and retinal images labeled for diabetic retinopathy. Evaluate the model performance on detecting diabetic retinopathy. Fine-tuned model achieve high accuracy in detecting diabetic retinopathy, significantly improving over traditional methods that demonstrate the effectiveness of transfer learning in medical diagnostics. Future directions in transfer learning. As the field transfer learning continues to evolve, several promising research directions are being explored. Improving transferability, developing new techniques to improve the transferability of futures, and learning by pre-trained models across diverse task domains. Automated transfer learning, cross model transfer learning, and efficient transfer learning. Thank you for joining me today for our Future Minds Gen AI Data Science podcast. I hope you found this exploration of transfer learning as enlightening and inspiring as I did. Until next time, I am Manav signing off. Stay curious, stay inspired, keep exploring.